Hey guys, this is Carrie, and in this video, this is the answer key for homework number 7. So we got x to the a times x to the third equals 12. We know that when we're multiplying two common bases, we add the exponents. So we see that x to the a plus 3 needs to equal x to the 12. To make these match, a plus 3 must be 12. Which means that a must be 9. For the second equation, x squared to the b power equals x to the 14th. When we have a power of a power, we multiply them. For these to be equal, we see that this and this have to be equal, because the bases are already equal, x and x. That gives us b equals 7. Finally, that means that a plus b is equal to 9 plus 7, 16. Rewrite the following as a single radical. So my preference would be to use our exponent rules here. So because we have our exponent rules, let's rewrite these as exponents. So you get x to the 2/3 using power over root times x to the 1/4. Because we're multiplying, we need to add the exponents. However, to add two fractions, we need a common denominator. So let's multiply by 4 and by 3 here and here. That will give us x to the 8/12 plus 3/12, x to the 11/12, which we can rewrite as the 12th root of x to the 11th. Alright, completely factor. Oh man! So we try our methods. GCF. 6 and 7 share no common factors. GCF is out. Sum and product. Because of the coefficient here, it can't be sum and product. It's definitely not difference of two squares. It's definitely not grouping. So unfortunately, it's whack. Which means that we have to use the it's whack method. So step 1 in this method is we set up 4 slots. We try to find the first, which is always the same, and the last, which is always the same. Now to find these two mystery terms, these mystery terms need to recombine, add to make 7x, the middle term here, and they need to have the same product as the first and last here. So the only numbers that do that are 3x and 4x. So we have plus 3x and plus 4x. Now, with 4 terms, we can actually use grouping. So we split it here, and we get 3x times 2x plus 1, and 2 times 2x plus 1. That becomes 2x plus 1 times 3x plus 2. Can't solve it because it wasn't equal to 0 or equal to anything to begin with. Completely factor. This is a difference of two squares problem because we have a difference, two perfect squares. So we get 5 minus 2x times 5 plus 2x, because 5 times 5 is 25, and negative 2x times 2x is negative 4x squared. For this one, you might think, oh man, it's whack again because we've got the coefficient, but don't be so fast. Because we have a common divisor of 3x, we can factor that out from each term, which leaves us with 3x times x squared minus 5x minus 6. And then this red group in parentheses can be factored using the difference, no, not the difference of squares method, the sum and product method. So we set up our parentheses, x times x is x squared. Now we're looking for two numbers that add to negative 5 and multiply to negative 6. Those are negative 6 and positive 1. Next up for problem 6, completely factor this one. My first instinct might be GCF, but 4 and 9 share nothing in common, and the variable groups also share nothing in common. So GCF is out. It means it has to be a difference of two squares problem because of the structure. We've got a difference, two perfect squares. Alright, so we set it up. 2 times 2 is 4, x to the 4th times x to the 4th is x to the 8th, y to the 5th times y to the 5th is y to the 10th, minus 3z times positive 3z gives us negative 9z squared. For problem 7, completely factor this. Alright, because we have 4 terms, it's got to be grouping. We split it here. This is going to be 2x squared times 3x plus 2 minus 5 times 3x plus 2, 2x squared minus 5 times 3x plus 2. Final answer, put it in a box, and we're done. Good luck on your test tomorrow, guys. Make sure your binder is all in order because you have a binder check coming up tomorrow as well, or the next time we have class.